All right.
Would you mind turning some of the lights on the other side of there off, just the ones in the front, so we can see the images a little bit better?
All right, so Taylor does not have a voice this morning, so I will be doing my best to fill his part. And for those of you who don't know, lovely Bridget. You all know Justin and myself. Anyway, let's look at some of our pictures to start off. All right, so this is the picture we got from the book. That is butterfly scales, and this is the image that we began with. Then you get to see a little bit of work in action and our final project. Justin's going to tell you a little bit about our picture.
See, if you were going to connect this to science, you could easily connect this to taxonomy and classification of different things. This is butterfly scales, so it would be an insect, and you could connect it to the different levels of classification, like kingdom. It would be Animalia, phylum, arthropods, and then class insects. And butterflies fall into Lepidoptera, which means scaly wings, and they've got little scales on their wings. And that is why they're called, or fall into this category of Lepidoptera. Fun fact is silk comes from the cocoon of a moth, which is also in the order Lepidoptera, and they have scales on their wings as well. And you could also connect this in science concepts to mimicry and like cryptic coloration, because as butterflies use their scales as their color, and for like cryptic coloration, there's some butterflies that hide themselves, they like fit in, make themselves look like trees, and that's all because of their scales. And there's also butterflies that mimic other butterflies, and they mimic other butterflies because some butterflies are poisonous or at least toxic, so other creatures do not want to eat them.
We're going to talk about the art part of this integration project. So split complementary is choosing one color and then using the color on each side of the color. So for example, if you choose orange and red, complementary colors are the colors you choose and using the opposite of the wheel. So examples like blue and orange, red and green, and yellow and purple. Primary colors are, of course, as we know, is red, blue, and yellow, and when you mix those, you make the secondary colors, which are the orange, green, and purple. Analogous color scheme is what we mainly also use, which is the same spectrum, so we used yellow, orange, and red, and so that's how we used the analogous, and we also used the primary and also the complementary, so it makes the vibration of the eye. The warm and cool colors, so warm colors are the red, yellow, and orange, and then the cool colors are the green, blue, and purple. And when you put these together, it creates a contrast for, and it makes your eyes vibrate, and that's why sometimes it's hard to look at colors that are opposite of the color spectrum.
Okay, so I'm speaking for Taylor. Do you want me to read this? Oh, thank you. Okay. So our article was Cell Organelles and Silk Batik, a model for integrating art and science. So let me see what you got here. Okay. Talk about. So this is integrated as an instructional approach. I like this idea a lot. I don't know if I'm actually going to portray everything you wanted to say, so I'm sorry. But he said to remember, I'm very tall and handsome. And this article explains how to engage students in creative integration. And it also includes the 5 E's for those of you who haven't heard. That is engage, explore, explain, elaborate, and evaluate. Very good. So it's actually really similar to the project that we did ourselves, but the article talks about how you would do it with students drawing the cell and cell organelles. So essentially you're using the same materials. It talks about the same site that we had on the board earlier, those types of things. Oh, okay. So, I'm sorry. I'm trying to do what you said. We're going to have class